Welcome everyone and welcome to our sessions on artificial intelligence. So in the previous sessions we just learned about what are all the technologies or what are all the prerequisites that we need to perform some operations on machine learning. So today what we'll be doing is we'll be learning on a simple concept called as linear regression. So we'll be going through some basics, that is nothing but some recap that we already studied, and then we'll implement our linear regression using Python. So we have a package called as scikit-learn. So scikit-learn is nothing but the package in Python that has all the machine learning libraries as well as all the machine learning algorithms which are inbuilt into it. So you don't need to worry about writing all the complex algorithms. You just need to understand how the algorithm works and which algorithm you need to use for your function. So one major thing is you need to understand the algorithms first, and after understanding the algorithms you should know which algorithm to use when and what is the exact requirement or the predictions that we need at the end. So what we'll do is we'll start with the recap of the previous sessions. We'll just understand or recap with the regression and classification concepts, and then we can move on with our linear regression part. So in the previous sessions itself, we have seen what is regression and how regression works. So basically regressions means nothing but if you have a set of values but you are able to predict the future values or the previous values using the set of values, so that is called as regression. So the best example of regression is whenever you are plotting your graphs in school between your x-axis and y-axis and you are trying to determine the results. So what you do is whenever you don't get a straight line, you try to draw the line that is best fitting. That is nothing but you try to draw the line which covers most of the points. So similarly, what we can do in regression is if we have a set of points or data, we can take the data and we can draw a line which passes through most of the data, and using that line we can predict our previous as well as our future values. So regression is nothing but whenever we have a set of data, we want to predict some future values as well as the past values. So using the data, you need to predict what is the future or what is the previous value. So the best example that I want to tell you is predicting the marks scored by a person using the previous marks. So that is regression. But we have another concept called as classification. So what is classification is? Classification is categorizing the data. So when you have 10 data that is available with you, you are either classifying it as group 1 or group 2. So if you have email in your inbox, so you are either classifying your email as your spam email or a non-spam email. So that is the whole difference between your classification and regression. But to start with, we will deal with the regression principles and we'll understand what we are trying to do. Yeah, coming to machine learning. So the first thing that we'll be doing is called as regression. So what is regression and how we are trying to understand is pretty simple. So in machine learning, I already told you we have two types of learning. One is supervised and unsupervised. So what is supervised learning? You already know what you need to predict, but you are training your data according to it. Unsupervised, you don't know what is the data to be predicted, but just you cluster with the help of the examples that is available. So that is how we can differentiate between supervised and unsupervised learning. But one thing we need to consider here is we need to understand what is the regression and difference. We understood the difference between our regression and as well as our classification. So what we'll be doing is in our regression, we have our first algorithm that is nothing but our linear regression. So we'll understand what is linear regression and how linear regression is helping us predict something. So how linear regression is helping us to predict our future values. So this is the algorithm that we'll be dealing right now. So the algorithm is called as linear regression. Yeah guys, so here we have a data which is very simple. So before understanding linear regression, we'll try to understand how linear regression actually is being represented, or why do we need to learn these regression principles. So one kind of way that we learn is pretty simple. So we have in our X, that is nothing but a data which has number of apples. So we have number of apples 1, 2, 3, 4, 5, 6. So these are the number of apples. And in the Y we have nothing but, that is nothing but cost per apple. So what is the cost per apple? For one apple it costs 50 rupees. For two apples it costs 100 rupees. For three apples 150. For 4 apples it is 200, similarly 250 and 300. So this is the data that I have. So what is linear regression is pretty simple. So whenever you want to establish the relationship between the known variable as well as the unknown variable. So what is the relationship between the dependent and independent variables, or the relationship between your two different types of data? All these things are examples of linear regression. So regression is nothing but finding out the relationship between the independent and dependent variables. So that is what is our regression principle doing in. So what is linear regression is nothing but finding a linear method or linear way for finding out the relationship between your x and y. So what is the linear method or linear way? I'll tell you. So regression is nothing but finding out the relationship between your x and y are independent or dependent. So if you have multiple variables, you will have x1, x2, x3, y1, y2, y3. So finding out the relationship between x1, x2, x3 and y1, y2, y3 is pretty simple. So one thing is finding out the relationship between x and y. So how do you find out relationship between x and y here? So for one apple it is 50, for two apple it is 100, for three apple it is 150. Basically what you are telling is you have your y is nothing but your 50x. So your formula is nothing but y is equal to 50x. So what is y is equal to 50x telling you? So y is equal to 50x is our actual formula. Why? Because whenever we have our y value, whenever we put 1 in x, it is nothing but 50. So if x is equal to 1, y is equal to 50. If x is equal to 2, y is equal to 100. If x is equal to 3, y is equal to 150. So this is the basic relationship we established. Okay. So this is nothing but the regression variable or the regression equation. So this is the regression equation. So this is like similarly how you draw your linear expression or the linear variable evaluation. So basically we have a linear equations, that is y is equal to mx plus y, like mx plus c is one type of equation. So y is equal to mx plus c is one type of equation. Here c is 0, so this is the form of a linear equation or a linear line. So what we understood is whenever we have a data, so whenever we want to try and find out the relationship between your x and y, so which is the independent variable here? Independent variable is the x, because x doesn't depend on anything, but y is our dependent variable. Why dependent variable? So because our y value depends on the value of x. So this is how we find out a relationship between your y and x. Okay, so this is called as regression. So what are we doing here? We have our x data, that is nothing but number of apples. Y is nothing but cost per apple. So what we are doing is we are trying to relate them. How are we trying to relate them? So finding out an equation which will try to like relate these two variables x and y. So we found out that y is equal to 50x is the equation, because for when x is equal to 1, y is equal to 50. When x is equal to 2, y is equal to 100. So y is equal to 50x is the correct equation. So whenever we replace this, we get all the correct values. So this is the scenario where we find out the relationship between our, that is nothing but our x and y. So what is, this is regression principle. So what is our linear regression is pretty simple. So when I have a graph, that is nothing but when I have a graph of x versus y. So this is my graph of x versus y. Yeah, so this will be my x-axis. So this will be my y-axis. So what I am trying to do is I am going to plot my x versus y. So what I will do is I will just draw some simple points or nothing but simple circles which will tell me what is the value of my x versus y. So if I have x is equal to, okay, we'll just do it in a simple way. So here we have 1. So here we have 2. So 3, and similarly we have 4 and we have 5. So this is telling us the number of apples. So this is the x-axis. Okay. So then similarly we have our y-axis. So what is our y-axis telling us? It is having data about all our individual elements. For example, we have 50, then we have 100. So then we have 150. So this is our y-axis. So this is nothing but the cost per apple that we are having. So basically what we are trying to do is when we are trying to plot our relationship between x and y. So we have our graph that is for nothing but y is equal to 50x. So whenever we try to draw a line, so whenever we try to draw a simple line, so what happens is, it is pretty simple. So you will get a straight line. So why do you get a straight line? When x is equal to 1, that is nothing but for one apple, we are paying nothing but 50 rupees. So that is how we are finding out the graph between these two parts. So whenever you have one apple, that is nothing but whenever you have one apple, so it is nothing but 50 rupees. So whenever you have 2 apples, it is nothing but your 100 rupees. So whenever you have 3 apples, it is nothing but your like 150 rupees, then 4 apples it is 200, then 5 apples, and that is how your relationship is being formed. But here the main thing is you don't have any situations where a straight line cannot be drawn, because since this is a linear representation, for 1 it is 50, for 2 it is 100, for 3 it is 150, for 4 it is 200. You can't draw a curved line like this. So you don't get a hyperbolic line like this. Always you will get a straight line. So this is in the case of an ideal scenario. So what is linear regression is nothing but drawing a line which fits all the points. So what are the points that we are trying to fit in here? So this is one point. This is the second point that I am going to fit here. So what I am trying to do is I am trying to fit the data. So this is one point. This is another point, that is nothing but my data is in here, second. So this is the line. So this is my third line. So similarly I have my fourth point. So all these points are passing through the straight line properly. So there is no difference, or there is no like a point which is there here. So I don't need to draw a like haphazard line here. So this is in an ideal scenario. So what is linear regression is pretty simple. So whenever you have your points plotted on the graph using your expression, you need to fit the best straight line. So you need to fit the best straight line for your data. So what is happening here is there is only one line, so that is the best fit line, because you don't have any point outside which doesn't appear in the graph. So all the points are linear because there is a linear establishment between your x and y. So since there is a linear establishment between your x and y, so all the points will fit in a straight line. So this is what I wanted to tell you. So in ideal situations, you have a straight line where all the points are fitting. So this is the straight line. So what will you do with the linear regression? So linear regression is nothing but whenever I have points here, so if I plot a straight line passing through all the points or most of the points, so this is the linear regression line. So what can I do with linear regression line is, so if I have data, that is nothing but if I have some other data like okay, for 7 apples, so what is my data? I can just interpolate this line. So I can see where my line is going to pass through, and I can find out what is the next relationship here. So that is what I can do. So for example, if I have my x is equal to 7, so I can interpolate or nothing but draw a line that touches my graph. So after touching that, I can draw a line to the y-axis also to find out what is the value that I have for my x. So this is how you are predicting new values in your linear regression. So very simple to understand. Regression is nothing but whenever you are establishing your relationship between your x and y variables, that is called as regression. But in case of a linear regression, what we are trying to do is, it is pretty simple. So we are trying to draw a straight line amongst all the points. So whenever you try to draw a straight line amongst all the points, so if you want to find out the intermediate values, you can just draw lines from your x-axis and y-axis. So wherever that point meets, so you can interpolate it to the other axis, so that will give you the values there. So that is how you are predicting new values. For example, when x is equal to 7, so you can easily predict it as 350 because you have drawn a straight line through the graph. So when x is equal to 7, whenever you meet at the point on the linear line that you have drawn, so when you interpolate that graphs, you will get the point where for x is equal to 7, what is the y value that you will get. So this is how linear regression works. But the scenario will not be same every time, because every time your graphs won't be linear. So this is what I wanted to tell you. So how will we do that particular thing is pretty simple. So as you can see now in our next example that we are trying to deal with, in the previous example we saw that there is a straight line that is passing through. You can't draw any other lines because the relationship between all the points is linear. So you can directly draw a straight line. But in case of this, we have different. So for 1 apple it is 20, for 2 apples it is 45. I mean it should be 40, right? But there are some situations in real life where the data is not linear always. For example, for 1 apple it is 20, for 2 apples it is 45. It is meaning that it is not a linear relationship that is being involved. For 3 apples it is 40, for 4 apples it is 60, for 5 apples it is 90, for 6 it is 120. Okay, there is some linear relationship, but again, the data is not linear throughout. So you can't form a direct equation like y is equal to 50x. So in that case, what do we do is the question. So what we'll do is pretty simple. So we'll take in or we'll plot in the data. So here is one data, here is the second data. So we have our third data here, then fourth data here, so fifth data. So what we have is the data is not linear. So every time the data is varying slightly. So that is how we have our data being arranged. So this is how our data looks because it is not in a linear relationship. So whenever we have data which is not in a linear relationship, we can't draw a straight line. In case of our example, that is nothing but y is equal to 50x. There is only one possibility to draw all the points to this line or draw a line to all these points. So, but here there are multiple possibilities. So I can draw a line here to here to here to all the points. So what we'll do is like the concept that we learned in our high school. So what did we learn in our high school? We will draw a line which passes through majority of the points. So what we'll do is we should draw a line which passes through the majority of the points. So what we'll do is we'll just draw a simple line. So this is how we are able to draw a line which is passing through our majority of the points. So this is how linear regression is established. So what we do is we remove out all these external factors. So we are not considering these external factors. What we are doing is we are considering only the factors where we can actually get some result out of it. So what if I draw a line over here? Okay, so what if I draw a line over here? So that is nothing but I have a problem because all these points are not passing through my line. So what we'll do is we'll draw a line which passes through most of the points. So this is how linear regression is helping us predict new values. So in ideal situations, you have only one possible way. But in case of your non-ideal situations, you have 100 possible ways because the data is not linear. I can draw this, I can draw like this. So which do you think is like the best fit line? So which do you think is the best line to handle is the question that we'll have. Okay, so one thing is for linear regression, we need to establish the relationship between x and y and we need to draw a straight line. Using the straight line, we can predict what is the next value. By having x, we can predict y. So that is how nothing but we are establishing the relationship between our independent and dependent variables. But one thing we need to find out here is what is exactly the thing that we need to do? What is the thing that we need to do is pretty simple. So when we draw a line that is passing through most of the points, but when I draw a line which is passing through most of the points, I can draw another line also parallel to it, which is also passing through most of the points. So in these two lines, which is the best line or how do we think which is the line that we should consider? In this case, what we'll do is pretty simple. So using the concept of our distance formula. So distance formula is pretty simple. So whenever you can use your distance, so the distance formula is pretty simple. It is nothing but your root of x2 minus x1 the whole square minus plus y2 minus y1 the whole square. So this is the formula that we will be using to find out the distance. So what we will do is pretty simple. We will try to calculate the distance between the points. So what is the distance between the points that we'll try to calculate? It is pretty simple using our distance formula which we learnt in our high school. So how will we calculate the distances? So one thing is we will draw the line, that is nothing but we will draw one line. So after drawing one line, we'll try to calculate the distance between this point and this line, distance between this point and this line. Yeah, so the distance between here. So each and every individual distances between each point and the line is calculated. So what we are trying to do is by crude way we can establish some best fit line, but actually mathematically we are trying to find out the distance between each and every point and the line that we have drawn. So similarly, if we have another line that we are drawing, that is nothing but if we have the second line that we are drawing, so what we will do is we will try to draw or get the distance between that point and this line and as well as all the points. So that is how you are establishing the distance between all these points. So best way to understand this is in a crude way we can tell that this is the best fit line because it is passing through most of the points. But you can draw multiple lines which is passing through most of the points. But how do we tell which is the best line for this easily solvable or non-linear data? So whenever we have non-linear data, that is a problem. But when we have linear data, there is only one line that we can draw which is nothing but which passes through all the points. So we need to understand the relationship here. So whenever we have non-linear data, what we are trying to do is, using the distance formula, we are trying to calculate the distance between our line that we have drawn as well as the point. So this distance is called as residual. So this is a very important term that we try to understand. So this distance is called as residual. So whenever we have our distance, that is nothing but the residual. So we try to find out the residual for each and every point. So this is how we are able to form a linear relationship. So step 1 is, to check the best fit line, what we'll do is, step 1 is nothing but find out the residual. So what is residual? The distance between the line as well as the point. So each distance is called residual. So we can call this as R1. So we can call this as R1, we can call this as R2. So this is how residual is found out. So it is nothing but the linear distance or a straight line distance that you need to find out between each and every point and the line. So after finding out the distance, there is one possible thinking. So since we have our nothing but we have our x2 and y1. So if we have distances that are below this particular line, so the distances will be positive. If we have distances, or if we are calculating distances for points that are above the line, then we have negative. Okay, so what is the problem here? So when we are calculating the distances here, that is nothing but above the line, we have negative. Because why? This point is nothing but at a positive place, and nothing but here it is a negative. So x2 will become less and x1 will become more. So it will become a negative distance. So that is the problem in case if we calculate our nothing but distances only. So what we do is we calculate the square of distances. So what we do is we calculate the square of distances. So what happens is, we will try to find the differences between our x minus y, then we will try to square them. So if we are trying to solve any problem, it is pretty so this is better. So what is happening now is pretty simple. So we have our data, that is we are having these distances. So whenever we try to calculate the distance, that is nothing but this is the d1 distance that we are trying to calculate, and this is the d2 distance that we are calculating. So this is the d3 and d4. So since our points are here and our axis is here, so since this axis nothing but x2 is greater than x1, so we'll have all the d1s, that is positive values. So all this d1 and d2 will be positive values, that is the distances. But here what we will have is negative values. Okay, so what we will do is, when we try to find out the distances, so we need to get the least distances. But if we have this negative values as our distances here and here, so what is the problem here? So this positive and negative will get subtracted and we will get a very small value. But that is a misleading value, because distances should never be negative. So what we will try to do is, we will square the distances. So second part is squaring the distances. So what is nothing but, we have our d1, that is distance 1, we will square the distance. So okay, we have our distance d1, so we will try to square it up. So each and every distance we will try to square it up. So d1 square plus, we will have our d2 square plus d3 square plus d4 square. So understood, guys? So very important to understand. It is pretty simple to understand, guys. So this is my x1 y1. So this is my x1 y1. So this is my x2 y2. Okay, so this is my x1 y1, this is my x2 y2. So what happens is, whenever I am trying to find out the distance, what is the distance? x2 minus x1 the whole square, y2 minus y1 the whole square. So you can see in the axis, so these 2 points, that is nothing but the line is actually greater, because x2 is here, x1 is here. So we will get a positive values for the points that are below the line. Okay, so similarly, if we do the same thing here, so this will be my x1, x2, like nothing but x2, y2. So this should be my x1, y1, because I am trying to calculate the distance. So here what you can see is, x2 y2 is at a lower point and x1 y1 is at a higher point. So x1 will be greater than x2. So whenever you are trying to find out the distance, it will be negative. So what will happen if you have negative? So totally, how will you find the best fit line? It is nothing but calculating the sum of all the distances. If distance is equal to minimum, if sum of distance is equal to minimum, so for different lines, so then that is the best fit line. Okay, now what is the problem is, since we have negative and positive here, so if we try to add them, obviously we'll get a minimum value. So that is wrong, because we don't want a negative distance here, we want a positive distance here. So how will you get a positive value? We'll square this. So we'll square each of the distance d1 square plus d2 square plus d3 square plus d4 square. So that is how we are getting positive distances. Okay, so now what we are trying to do is, if square of the distances is equal to minimum, then it is best fit line. So this is how your linear regression works. So how it is doing is, whenever you have a non-linear data that you have with you, so first it is going to draw different lines. So for each and every line, it will try to calculate the distance between each and every point and the line. Then it is going to square the distance. Okay. So after squaring the distance, what it is doing is, it is telling you that after squaring the distance, if I sum all the respective distances, if the distance is minimum, so that is my best fit line that I can choose. So whenever I have a best fit line, it is simple. So I can extrapolate my x versus y to find out any previous value. So if I extend this graph to a larger value, I can find out what is my future values. So that is how I can do all these particular things. So very simple to understand. In case of linear expressions, what you have, that is nothing but you have a problem of data that is being only one straight line is possible. But in case of non-linear expressions, what is happening? Data is getting split or separated into different parts, where you can't draw a straight line which is passing through all the points. So what you do, you use your high school technique to pass it through most of the points. But even if you pass it through most of the points, there are some cases where even if you pass it through most of the points, there are multiple lines which can pass through most of the points. So how will you calculate which is the best line? In a mathematical way. In a mathematical way, we use our distance formula, where we try to calculate the distance between our nothing but the point as well as our line. So here also each and every distance we calculate. Since just calculating the distance will give positive and negative values, if you add all the distances, there will be error, because some negative values are also getting added. So we need to square the distances and add them. So after squaring the distances and adding them, so if we get the minimum value of these square of distances, so then it is the best fit line. So in mathematical term, what we can tell is, if mean squared error. So what is mean squared error? So it is nothing but calculating the sum of all the squared distances. If mean squared error is minimum, then it is a best fit line. So this is how you understand the linear regression. So this is the mathematical aspect. So what we'll be trying to do is, we'll have different data sets. We'll have different data sets of x and y. So what we'll do is, whenever we have our x and y our data set, whenever we pass it through a linear regression algorithm, so it will predict or nothing but find out the relationship between x and y. So since the data is not linear, actually in practically we'll have millions of data. Data is not linear. We'll try to draw a best fit line using this principle. Calculate the distance using distance formula, square the distance, add each and every distance of the point from the line. So which line has the minimum distance? So that is the best fit line to include in your particular linear regression. So that is how the best fit line principle works.